Dear students, now let us try another example. The example is like this: the centrifugal force of the body depends force of the body revolving around a circular path depends upon number one, mass of the body, velocity of the body, and radius of the circular path. Now what we'll do is we'll reduce an expression for centrifugal force. Now centrifugal force F depends upon mass of the body and velocity of the body, and lastly the radius of the circular path. So we write it as F proportional to this centrifugal force, F proportional to M, V and R. So we can write it as F equals to some constant K into M to the power of A, V to the power of B and R to the power of C. This is your equation number 1. Now let us write dimensions on both sides. If you write dimensions on both sides, it looks like this. Let us write the dimensions now. So if you write the dimension of force, the dimension of force is M1 L1 T minus 2. This is the dimension of force. Now this is dimensionless constant, so you need not write dimension here. Let us write the dimension of mass. So this is equal to dimension of mass is M to the power of A. Then we write the dimension of velocity. The dimension of velocity is L T to the power of minus 1 to the power of B. And then we write dimension of radius. Radius is nothing but L to the power of C. So after writing dimension of both sides, we can write it as M1 L1 T minus 2, and here we can write it as M to the power of A, then L to the power of B and L to the power of C. So we can write it as L to the power of B plus C. And lastly, we can write T to the power of minus B, T to the power of minus B. Now we'll find out the values of A, B and C. So if you equate both sides, we can write A is equal to 1 because M to the power of A and M to the power of 1. So A is equal to 1. Now we can write B plus C. So B plus C is L to the power of 1. L to the power of B plus C is L to the power of 1. So B plus C is equal to 1. And then we can write minus B is equal to minus 2. T to the power of minus B and T to the power of minus 2. So minus B equals to minus 2. So from here we can write B equals 2. Now we already got A equals to 1. We already got B equals to 2. Let us find out the value of C. So B plus C is equal to 1. That means C is equal to 1 minus B. So this is 1 minus B is 2 and it is equal to minus 1. So we got A equals to 1, we got B equals to 2 and C equals to minus 1. So let us put out the values here. So if you put the values here, we can write F equals to K into M to the power of A. So M to the power of A. A is your 1. Then we can write B to the power of B. So B to the power of B is B squared. And then R to the power of C. The R to the power of C is minus 1. So we can write it as F equals to K into M V squared by R. So this is the expression for centrifugal force. Now remember, as I told you, that K is to be found out experimentally. It cannot be found out dimensionally. So you can write K equals to 1. This is experimentally. You cannot find out with dimension. Only by further studies you will find out the value of K is equal to 1. So then you can write F equals to how much? Mv squared divided by R. So this is the expression for centrifugal force. Now remember, with the help of dimension, you can find out up to till this value. This is your answer. This you will know later on. So here till here is your answer. Thank you very much. Now let us try another example. The example question is like this. This is the question. This is the question. The question is assuming that the critical velocity of a flow of liquid through a narrow tube depends upon the radius of the tube, density of the liquid, and viscosity of the liquid. Find an expression for critical velocity. Now, so three things it depends upon. Critical velocity. See, this is critical velocity. Now, critical velocity is v. Any velocity is v in dimension. So this critical velocity is v. Critical velocity depends upon three things. Number one, it depends upon the radius of the tube. So radius of the tube is r. Then it depends upon density of the liquid. The density is rho. And lastly, it depends upon viscosity of the liquid. Now, if you go to dimension, viscosity is represented by eta. This is viscosity. Now, we must know dimension of r. R, you know, is length. Now, what is rho? Rho is density. Now, density is mass per unit volume. So, this is density is m1 L to the power of minus 3. This is the dimension of density. Now, what is the dimension of eta? This is coefficient of viscosity. Now, if you go through the chart, you will find out the coefficient of viscosity dimension is m1 L minus 1 and T minus 1. So, these are the things that we will be using. So, what we write here is V is equal to some constant into r to the power of a, eta to the power of b, and rho to the power of b, and eta to the power of c. So this is your equation number 1. So we'll put the values of a, b, and c. Now let us write the dimensions on both sides. Let us write dimensions on both sides. If you write dimension on both sides, this is velocity. The velocity is m0 L1 T minus 1. This is velocity. Then K is dimensionless. It does not have any dimension. This is radius. Radius is L to the power of A. And this is density. Density is, here it is density. It is M1 L minus 3 to the power of B. And then eta. Eta is M1 L minus 1 T minus 1 to the power of C. Now, let us find out the values of A, B, and C. So, this can be written as how much is M equal to M to the power of B and M to the power of C. So, you can write M to the power of B plus C. M to the power of B and M to the power of C. This is M to the power of B plus C. How much is M? M to the power of A is there. M to the power of, then this is M to the power of minus 3B. So, this is minus 3B. Another L here. So this is L to the power of minus 1 and C here. So this is minus C. So A is A, then L to the power of minus 3B, and lastly L to the power of minus C. And then we have T. Now no T here, it's only one T here. So T to the power of minus C. Now we compare both sides. This side, remember, it is M to the power of 0, L1 and T minus 1. Now let us find out the values of A, B, and C. Let us find out the values of A, B, and C. So we have what we have here. We have B plus C is equal to 0. B plus C equals to 0. Then minus A minus 3B, A minus 3B minus C is equal to how much? 1. And then lastly we have minus C, this minus T to the power of minus C and T to the power of minus 1. So minus C is minus 1. Now let us find out the values of ABC. From here clearly we can say that this implies that C equals to 1. Now if C is equal to 1, from here it implies that B is equal to minus C. So if B is equal to minus C and C equals to 1, so we can write B is equal to minus 1. Now from here, let us find out how much A equals to. So A is equal to, we can write 1 plus 3B plus C. So let us find out values. It's 1 plus 3B. B is minus 1. So we can write it as 1 minus 3. 1 minus 3 plus C, and C is your 1. So you see, it's a minus 3, this is plus 1, this is minus 3, this is plus 1 and plus 1. So what will be the value here? This value is, this is plus 1 and plus 1, so this is minus 1. So let's find out the values of A, then we find out the values of B. This is A, this is B, and this is C. So let us find out, this is your A. A is your minus 1, then your B is again minus 1, and your C is only 1. So let us put the values here. If you put the values here, then B comes out to be, B is equal to K into R to the power of A. A is your minus 1. Rho to the power of B. How much is B? B is again minus 1. And eta to the power of C. Eta to the power of C is your eta to the power of 1. So we can write B equals to K into eta divided by, this is eta. Eta divided by R rho. So this is the answer for critical velocity. B equals to K into eta into R to the power of rho. R rho. The K is found out experimentally, so you need not find out the values. This is the final expression. So B equals to K into eta divided by R rho. This is the critical velocity expression. We will find out with the help of dimension.